Alrighty, hello and welcome to today's video. In today's video, I'm going to be doing another application of calculus. This time, we're going to be trying to find the formula for a sphere. Now you might ask, how's that different from a circle? Well, a sphere is in 3D space, so we have to go a step further than when we were doing the circle. We have to rotate it about the x or the y axis. In this case, I believe it will be easier to rotate it around about the x-axis because of the formulas that we've previously derived. Well, because we're looking for a general formula here, we can't use numbers. So, we're drawing our form or graph of our circle here. We're going to say that all of these points are r away from the origin or the center of the circle or radius. But sadly, this right here is not a function. We cannot integrate this. But we do know what this function, or what the formula would be, and that would be y squared plus x squared is equal to r squared. So now what we need to do is we need to get this y by itself. So we're going to get y squared is equal to r squared minus x squared. Then we're going to take the square root of both sides, so we get y is equal to the square root of r squared minus x squared. So what this graph right here really represents is just this top portion of this graph. So is this going to give us the entire area of the circle? No. So what we're going to do is we're still going to integrate this function. So we're going to take the integral from, and let's remember that our endpoints here, we have negative r and r. So we're going to be integrating from negative r to r. Well, what are we doing with this curve, really? Well, we're rotating this around the x-axis. This is making the graph into a circle with a radius with the height square root of r squared minus x squared. Using the formula for a circle, we know that this is going to be pi times by whatever this f function is, square root of r squared minus x squared squared. And we're integrating this with respect to x. Well, we're going to pull this pi out front, so we get pi times by the integral from negative r to r. This square and the square root will cancel each other, so we're left with r squared minus x squared dx. Integrating this now with respect to x, we get pi from negative r to r. The integral of r squared is just a constant here, so it's just going to be r squared x minus x cubed divided by 3. I don't know why I kept the integral sign there. And we're evaluating this integral from r to negative r. So we're now going to evaluate these two at these points, so we get r squared times by negative r minus negative r cubed divided by 3 minus, in parentheses, and I'm going to put another parenthesis there, or I suppose this should be positive r. I did this backwards. I apologize if this has caused confusion. So now we subtract the lower bound, which is going to be r squared times by negative r minus negative r cubed, alright, divided by 3. Well, now we just have to simplify this. So we get pi times by r cubed minus r cubed divided by 3 minus, in this case, because we're going to distribute this negative, it's going to be plus r cubed plus r cubed divided by 3, or sorry, minus r cubed divided by 3, if I can get a minus there. Alright, so we have pi. Let's get common denominators here. So this is going to be 3/3, so 2/3 pi or sorry, 2/3 of r cubed, plus 5/3 of r cubed, minus another third of r cubed. So that makes 4r cubed divided by 3. And finally, we just have to sum in our pi, so we get 4 pi r cubed, or 4/3 pi r cubed, or pi cubed. 4/3 pi r cubed. And that, my friends, is how we do derive the volume of a sphere using calculus. In the next video, I intend on deriving a formula for a cone. I hope you all have enjoyed, and if you did find this video informative, please just like. You've watched till the end, but this was a short video.